Welcome to another Math Is production. Today's video is all about writing proofs. First, let's review a few postulates and theorems from class. The linear pair postulate. If two angles are adjacent and form a straight line, then they are supplementary. The vertical angles theorem. If two straight lines intersect, then the angles are opposite of each other are congruent. Converse of corresponding angles postulate. If angle 1 is congruent to angle 7, or angle 2 is congruent to angle 8, then line L is parallel to line M. Or, if the measure of angle 1 is equal to the measure of angle 7, or the measure of angle 2 is equal to the measure of angle 8, then line L is parallel to line M. The properties of equality or congruence. Reflexive, transitive, symmetric, substitution, addition, subtraction, division, multiplication, and distributive. A few of the other definitions that we're going to cover are congruence, supplementary, and complementary.
Thanks, Mike, for explaining all the theorems. Now we're going to get into doing proofs. During class, a lot of people have had quite a bit of challenges, so I'm going to tell you how I think about things and, how I get to be able to do these two-column proofs, and I'll also introduce paragraph proofs. So the first thing you want to do in a proof is notice your given and your proof. Your given's always your step one, and you always want to end your proof on the proof part. So let's examine problem number 1. It says, given lines J and M intersect, we want to prove that angle 1, let me highlight angle 1. Angle 1 is congruent to angle 2. Let me highlight angle 2. Alright, so remember that step 1 is always just write down your given. You always want to receive points for at least writing down your given. So step 1, we were given that lines J and M intersect. Now, when I do proofs, I think about how my dad taught me to play chess. Every time I would move a piece, he literally would ask me why. And if I couldn't tell him why, then I could not move the piece. It's the same thing when we're writing proofs. Whenever you make a statement, you have to have your reason why. If you don't have a reason why when you make a statement, then you can't write it down. So why do lines J and M intersect? Because you told me. It was given. So the reasons was given. Okay. So now we're trying to prove that angle 1 is congruent to angle 2. If I think back to the postulates and theorems that Mike gave me, the first postulate was the linear pair postulate. And I do see several linear pairs. So I'm going to try to utilize that. And then we'll see if that'll help us prove things. One thing about proofs that you can do is if you don't know where to go, write down something. You know something, right? So we know the linear pair postulate. We don't know if it's going to help us or not, but let's just write it down and see. So linear pair tells me that the measure of angle 1 plus the measure of angle 3, you see how they form a straight line? Equal 180. And that reason was the linear pair postulate. Well, some kind of way I have to relate angle 1 to angle 2. So I just said that the measure of angle 1 plus the measure of angle 3 equals 180. Well, angle 2 also forms a linear pair, so I can write that down as well. So actually right underneath it, I'm just going to write the measure of angle 2 plus the measure of angle 3 equals 180, and that's that same reasoning. So I'm just going to put it all in number 2. So while I'm doing a proof, so now I'm stuck. I don't know where to go. I see that the lines intersect, and I see that they're supplementary. So where can I go from here? Well, the first thing I do is I kind of look and I see if I notice anything. Well, one thing that I notice is that they're both equal to 180 and they both have the measurement of angle 3 in them. So since they both equal 180, it's reasonable for me to just say, hey, I can substitute 180 for one of these. So let's go ahead and do that. Crank out that substitution property. The measurement of angle 1 plus the measurement of angle 3 equals the measurement of angle 2 plus the measurement of angle 3. Sorry about the crampness. And we just substituted. So that's literally the substitution property of equality. That's why. Okay, I feel like I'm a little bit further. Now let's examine what we just wrote and see if we notice anything. Well, both sides have the measurement of angle 3 in them. So if I subtract, this is an equation, so I can subtract anything I want. I'm going to subtract the measurement of angle 3 from both sides. Well, when I subtract angle 3 from the left-hand side, all I'm left with is the measure of angle 1. That angle 3 goes away because I subtracted it. And when I subtract it from the right-hand side, all I'm left with is the measurement of angle 2. And remember, we just did the subtraction property of equality. I'm just going to abbreviate it POE. Well, gosh, the measure of angle 1 equals the measurement of angle 2. I'm trying to prove that they're congruent. If they're equal, then we know they're congruent by the definition of congruency. So, angle 1 is congruent to angle 2. And what's the reason? Definition of congruence. And that's our proof.